Mm.
Could you give us like three examples of how the new science is different than the original science that we are aware of?
Yeah. So new science. The first is a very general example, and it's good news for everybody who's using old science tools like computational models. It's okay to still do the experiments you were doing before, to model the world with computational models like you did before. But you will realize that these models, they are not more real than the real world that you live in. I always like to use this example of you can simulate your bike perfectly, but you can't write that simulation to work. This is a distinction that seems bleedingly obvious to everyone, but is often forgotten when you hear discussions about AI. Is AI conscious? It's a simulation of something, but we don't know even what consciousness is. So we have to make that distinction. So in this new science, you will not come up with a new technology and think, hey, this is how the world looks like. Because look, I have a really cool computer the size of my pocket. I have this phone that I can put, and this is the coolest technology we've ever come up with. This was just like the clockworks in the 17th century. They were so cool that everybody suddenly thought the world was a clock. And now our computers are so cool that we think the world is a computer. So you wouldn't do this anymore. So this is a very abstract example, right? So what are the more specific examples? One I've already given to you, and I think as a biologist is extremely important to me. I think cancer biology and research has been delayed by about 30 years by thinking about it in a reductionist way, which was completely wrong. So that identifying single targeted mutations that are causing a cancer. Cancers, unfortunately, are a very individual disease. Everybody has different mutations, and it's always a whole set of mutations. And of course, the genes that are involved are not cancer genes. They didn't evolve to cause cancer. They regulate growth processes. That's the bad thing. They usually regulate growth processes in cells, and we know that every gene basically in a cell is involved in regulating growth in some way or another, directly or indirectly. So we have to think about these network effects. We have to think about the different levels of organization that cancer works in. So you would naturally think this way, that cancer is a complex multi-level disease, and then you would have to justify why use a specific model targeting a specific level instead of saying, okay, we are just going to study oncogenes and tumor suppressor genes. And I do think research was held back, and a lot of people prematurely died for that reason. So it's not just a philosophical issue. And then the last example is my favorite example because it's what I work on and there's no other reason. And that is the science of the organism. Why don't we understand life? And why does biology not even ask the question what life is anymore? And that is connected also with the discussion we have about AI, by the way. That's really closely connected, because what I would claim is that there's pretty good evidence that what makes living systems alive is that they're just normal matter that's organized in a very unusual way. It's very fluid, dynamic. It's complex in a very different way than a self-organizing system like a candle flame is. It doesn't just dissipate energy, it reinvests that energy into its own existence. It has agency, so there are actions that come from within that organization. And I was, as a biologist, always struck how we don't even have the tools to understand and study that. And this is something that we would ask immediately, why is it possible that for about 70 years now, since we discovered DNA, biologists have just been focusing on molecules and mechanisms, and then have been believing that if you just study enough mechanisms, the meaning of life is going to jump out at you at some point, miraculously. And that's not happened for 70 years. And I think it's never going to happen because we simply lack the right concepts, the right ideas, the right questions to ask what life really is. So my own research is going beyond the age of machine, because there is work by a theoretical biologist called Robert Rosen from the 1950s already that is showing, using a very rigorous mathematical proof using category theory, that the kind of systems that living systems have to be, if they behave the way they do, is not the same as a Newtonian mechanism. It's simply not the same category of systems. And so we have to move beyond the age of machines, quite literally in biology, if we want to understand a whole living cell, a whole living organism, or ecosystems, or any system up to social systems and economies that contain living systems that behave in ways that mechanical systems don't. And our sciences, especially economics, is failing at that. That's why it's often called the dismal science, and